This is EMI Lab EMI20 from Emitech Electronics. We are discussing the equipment setup to set up the connection for the EMC analyzer with the oscilloscope. The oscilloscope is not being provided with the equipment, the lab has to use it from its own stock. We need to switch on the instrument from the back panel and the LED display will light up indicating the frequency in megahertz. This is the center frequency for the RF input to be connected at the SMA connector. The instrument is to be connected to the CRO using the BNC cables provided. A horizontal cable will connect to the X input of the CRO. The vertical input of the cable will connect to the Y input of the CRO. The CRO is a dual channel oscilloscope or an XY oscilloscope. In this particular oscilloscope, we have disabled the time mode and enabled the XY mode as is being shown here. Both the X and Y channels are being coupled in the DC mode. The AC mode of coupling is disabled. The vertical gain of the Y channel has been set to 500 millivolts per division. The horizontal gain for the X channel has been set to 500 millivolts per division. These are the default settings to ensure the calibration of the EMC analyzer. As the initial condition, the spot on the CRO, as is being visible here, the horizontal position of the spot has been made at the center of the graticule line, and the vertical position of the slot is set to -4 divisions from the center of the graticule. So to initialize, we need to set the CRO dot at this position. Now we connect the horizontal cable at the X input and we connect the vertical input to the Y channel. Now a display like that is being shown. At the bottom of it, it's the grass, and the horizontal axis is displaying the frequency, whereas the vertical amplitude is displaying the RF level in dBs. The horizontal line is right now displaying a frequency range from 0 megahertz to more than about 500 megahertz. The CRO center graticule is right now reading the frequency 249 megahertz, as is also being lit up on the center of the display. The amplitude in the Y channel is being calibrated to read -67 dBm at the center of the graticule when no attenuators are being provided or connected at the RF input of the EMC analyzer. Hence, the horizontal calibration has been discussed. Any frequency which will be displayed on the CRO can be read off using the sweep center control to bring in the sweep center to the desired frequency of interest, and its power level can be read off by absolute reference as -67 dBm, and the vertical channels are being set at 10 dB per 500 millivolts. Hence, each of these graticules are displaying a power level of 10 dB. Hence, this is -67 dBm, this is -77 dBm, this is -87 dBm, this is -97 dBm. So the EMC analyzer is a pretty sensitive equipment with a sensitivity of in the range of about -100 dBm. We'll discuss the next experiments by using the common setup like this. The equipment can also display a marker which can be enabled. Now this LED is being shifted to the marker, and the marker will cause a vertical marker on the CRO to be displayed, and any movement of this control will move the marker in the horizontal axis, and any frequency component can be read off by overlapping the marker to the frequency component in display. The marker can be switched off and the equipment will start displaying the frequency at the center of the graticule. The horizontal span of the EMC analyzer is not calibrated but can be read off using the sweep width control. We have also provided a video filter. Now you see, the moment the video filter is enabled, the video is being filtered out and very small signal levels which were up till now being drowned in the noise floor of the equipment can be made visible. Certain modulation characteristics can be enhanced by using the video filter. We'll move to the next experiment.